Hello my dear students, once again welcome to your online class. Today we will be continuing with the chapter Upthrust of your physics textbook, and today we will be understanding what is the density, the relative density and the different ways to find the relative density of the substance. So we have already studied about the density in our junior classes as well. So once again we will learn what is density. So density is defined as the mass per unit volume. Okay, so the definition of density is very simple. So what is it? The density can be defined as the mass per unit volume. So now coming to the unit of density, so we have two kinds of unit. One is the smaller unit, that is known as the CJ system, and the other is the larger unit, that is known as a SI system. So in CJ system, mass is measured in terms of gram and the volume is measured in terms of centimeter cube. So therefore the CJ's unit of density is gram per centimeter cube. And in the larger unit, we measure mass in terms of kilogram and volume in terms of meter cube. So therefore the SI unit of density is kg per meter cube. Now coming to the second important topic, that is the relative density. So whenever the word relative comes, the given quantity is compared to some standard quantity. So here that standard quantity is taken to be the density of a water. Now since we have learned about the anomalous expansion of water, that the water expands anomalously. So the standard unit of water is taken as the density of water at 4 degrees centigrade, which is usually 1000 kg per meter cube in SI system and 1 gram per centimeter cube in CJ system. So whenever we compare the density of a given substance to the density of water at 4 degrees centigrade, that is said to be the relative density. So the relative density is defined as it is the density of a substance divided by the density of water at 4 degree centigrade. So this is what the relative density means. So relative density means it is the density of a substance to the ratio of the density of substance to the density of water at 4 degree centigrade. Now coming to the unit, since the relative density is the ratio of same physical quantity, so therefore what happens, kg per meter cube and kg per meter cube, so both of them they cancel and it does not have any unit. So the relative density is a pure ratio, it does not have any kinds of unit. So now there are different ways to determine the density of a substance. So the first, what can you do, you can also use the formula like to find the density of substance. It is the ratio of the mass of a certain volume of substance divided by the mass of same volume of water. Okay, so this formula you can use as well to find the density of the substance. So what will you do, you will take a certain volume of a given substance and then you will also take the same volume of water and then find its mass and you can find the ratio. So that will also give the relative density. So now using the Archimedes principle as well, we can find the relative density of a substance. So how is that done? So using the Archimedes principle, suppose if you are given object of mass which weights, so I write, so the first observation is you will write, you are given an object, okay, you will with the help of the spring balance you will measure its mass, weight in air. Okay, so if it is W1, so what will you do? First you will measure the mass of the given substance in air, suspending it with a spring balance you will measure it. So if the weight is W1, so second what can you do? You will find the upthrust on that object when it is immersed in a water. Okay, so what will you do? You will take this and then you will put the whole thing in a liquid. Okay, so not liquid, sorry, in a water. So the second observation you will write is weight in water. Okay, suppose if it is W2, then what will be the upthrust? So simply the upthrust will be W2 minus the W1, that is the loss in weight of a object. So therefore the relative density of the given substance can be calculated by the weight of the body in air divided by the upthrust. That means the weight in air minus the weight in water. Okay, so this formula can be used to calculate the relative density of a given substance. Okay, so that is how we find the relative density of a given substance. So using the same principle as well, we can find the relative density of a given liquid also. Okay, so that is, so how to find the relative density? So this is for a solid. Okay, so for a solid, we use this formula to calculate the relative density. Now when it comes to the liquid, okay, since the liquid directly we cannot tie a liquid and measure it, so there is a definite way to find the weight of the liquid divided by the weight of the same volume of water. Okay, so let's try to find out how to find the relative density of a water. So now what can you do? So now to find the relative density of the liquid, what you do? We take the same object. Okay, so the first observation will be the weight of a body in air. So if it is W1. Okay, so now what will I do? I'll take the same object and insert it in a water. So the second one is the weight of a body in water. So if it is W2. Okay, and then finally, whichever liquid you are given to find the relative density, what will I do? I'll take that same object and immerse it in a given liquid. Okay, maybe it be a glycerin or any other substance. So what will you do? You'll take, so given liquid is here, and then what will I do? I'll take tie the same object and immerse it in a given liquid. So let the third observation be the weight of our body in liquid. Let that be W3. So now to find the relative density of the liquid, we use the formula. It will be W1, that is the weight of the body in air, minus W3, the weight of the body in a given liquid, divided by the W1 minus W2. Okay, so this is how we find the relative density of a given liquid. So here it is just like saying the upthrust in a given liquid divided by the upthrust in a water. Okay, so this was all about the relative density. You can see what is written in the board here. So it was the density, its unit, relative density, the way to find the relative density of a given substance, and the way to find the relative density of a given liquid. So now the last topic of this chapter is the principle of flotation. So now to understand this, what we could do, we take a liquid and then we immerse one body in a liquid. Okay, so we know that whenever an object is immersed in a liquid, there are two forces acting. One, the weight of the body that acts vertically downward, and the second one is the upthrust, FB, which acts vertically upward. So using this, like the concept of the weight and the upthrust, we can easily determine whether the body will float or sink, or it will just float under the surface of the liquid. So the first case is when the upthrust will be greater than the weight of the body. So obviously in this case the body will float. Okay, so it will float on the surface of the liquid. The second one is when the upthrust will be less than the weight of the body. So what happens? It will sink. Okay, so when the upthrust will be less than the weight of the body, what happens? The object will sink. And the third one is when the upthrust will be equal to the weight of the body, it will float just under the surface of the liquid. Okay, like for example ice. Okay, so if you see the ice, it will just float under the surface of the liquid with most of the part inside the liquid. So that is what the principle of flotation tells us. Or the principle of flotation, in the simple word you can tell that the principle of flotation states that the weight of the floating body will be equal to the weight of the liquid displaced by it. So this is all, and there are few applications of the principle of flotation given in your book. You can please refer your book and learn those examples, and I'll also provide you some notes and the solution to the exercise of your book, so you may write down that in your copy. So in the next class we'll be beginning a new chapter. Thank you. Stay safe.